So if this is true, if we have f is like, hold on, p x y q x y, it's like this. Gradient of f is if f with this vector field is a gradient of this of f, then they should be equal. That means therefore p xy should be equal to, this should be equal to this. And then this should be equal to this. But also we know according to Clorets theorem, this, I don't know if it's pronounced Clorets theorem, but it basically says derivating with respect to x first and then y is the same as derivating with respect to y first and then x. So derivative with respect to y is equal to f xy, and the derivative of this with respect to x is equal to this. So we have this, and then we are derivating with respect to the other variable. Since these two are equal, then these two has to be equal. And that means p xy is equal to q xy. So that means if for f xy, if f xy can be represented like this, derivating this with respect to y should be equal to derivating q with respect to x. If this vector field can have a gradient function, if this vector field is a gradient of another function, then this component with respect to the second component should be equal to this component, the derivative of this with respect to x. So f implies derivative of q with respect to y. Sorry, derivative of q with respect to x. Yeah. And if this part is not true, if this part is not true, that derivative of p with respect to y is not equal to derivative of q with respect to x. If this is not true, then there doesn't exist then the gradient of a function doesn't exist. There's no function which can be the gradient of this vector field. And for three dimensions, if we have x, y, p, q, and what's the other variable? P, q, and r. And then we have grad f, which is this. So some function f and the derivative with respect to x, and some function f derivative with respect to y, and then some function f derivative with respect to z. So there should, if these two are equal, there should exist some function f such that f with respect to x gives p, with respect to y gives q, with respect to z gives r. And then using the same logic as before, is equal to, like using the same argument as before, p with respect to y should be equal to q with respect to derivative of q with respect to x, and derivative of p with respect to z should equal to derivative of r with respect to x, and q with respect to z should be equal to r with respect to y. So this should be equal. That is called the gross partial property of conservative vector fields. If f is conservative, i.e., if this vector field has some it can be represented as a gradient of another function, then this part should be equal. Then then the gradient of p with respect to y should be equal to gradient of q with respect to x, and the other two conditions should be available as well.